fresh now after a good talk there and after lunch. I'm certainly feeling better, even though I got up at 4 AM. The last time I was here when we get in at 3 AM delegation from the sports bar in town. I work for Quotium. I've got 15 years experience in application lifecycle management and application quality assurance and application security as well as application performance. And there's a lot of synergies between those two, and this is going to be the kind of the basis of my talk and how that applies to PCI DSS. So what I'll say is the success and impact of a cyber attack largely depends on how secure the organisation's applications are. When applications have serious vulnerabilities, a cyber attack will easily succeed and the impact can be considerable. This talk is based on a white paper actually that we can get from our stand. It's actually based on version 2 of PCI. We're coming out with version 3 soon. And in version 2 we've seen a rising prevalence relating to application security. And that's not least because of the sort of attacks that we're seeing coming through the applications themselves. In the US edition of the Ponemon study, the 2012 cost of cyber crime, 3 of the most expensive types of cyber attacks, namely malicious insiders, malicious code and web-based attacks, accounted for 54% of cyber crime cost. These 3 are also the most difficult to solve, averaging 57.1 days for malicious insiders, 50.3 days for malicious code, and 37.9 days for web-based attacks. So the success rate and impact of those particular attacks can be considerably reduced, though, by strong application security. Because application security plays an important role in countering cyber attacks, it's given the utmost importance in PCI DSS, and certainly more so now. Security requirements governing software development, inscribed in Major Requirement 6, charges merchants to develop and maintain secure systems and applications, as we know. There are other requirements that have implied prescriptions for software developments, and they can be found under 3, 4, 8, and 11. Those requirements specify standards for the protection of stored cardholder data, encryption of cardholder data during transmission, assignment of a unique ID to each person who has computer access, and regular testing of systems and processes, respectively, for Section 11. So what I'm going to try and do now is put application security into context. Applications are really there to make data useful. They are therefore connected to the heart of the organisation. They're connected to the application's critical data. They're connected to the organisation's critical data. They're connected to the organisation's critical processes. And they're there to make data available to users. They might be staff, patients, soldiers, customers, what have you. Now, those users are looking for this information. They're looking to control the process inside the organisation that they need to control. So it might be to generate a phone bill. It might be to inquire a balance. It might be to instruct the bank to make a transfer or instruct their cardholder to make a payment. So what happens then is applications, in fact, present this data to hackers because they have to. Because you can't differentiate between a hacker and a real user. This layer, anybody could come in to hack it. Any one of you could decide, I'm going to be a hacker. There's no way that the system can decide if you're going to try and hack their application or not. So these applications then, the way that's done is by these hackers exploiting vulnerabilities in the application. The application teams are there to create highly functionally rich, high-performance applications. And typically, your average developer is not a security expert. So lots of users can use these applications and they're highly functional. But what about functions that are not supposed to be there? So any hacker can come and leverage the vulnerabilities in the application to get access to these critical processes and data. So you might be protected by the best network in the world. You might have the best software on your servers to protect yourself from hacks. But if the application itself is weak, because it's presented on port 80 or 443 via HTTP and HTTPS, then that's a vulnerability right there. It bypasses the network, it bypasses the server, because those pieces of hardware present the application to the user, i.e. the hacker, which allows the hacker to send in application security exploits, receive vulnerable information, control the processes that they need to control, and in some cases compromise other users. So by a cross-site attack, maybe cross-site scripting, cross-site, cross-forgery, for example, which could of course be used to install malware, and that would mean that the organization's application is used as a pivot point for attacks on other users of that application. So of course what are hackers looking for? Well, data really, confidentiality. If we use the SQL injection example, that's probably the most simple to understand. That's where we send database commands in via the interface of the application. If an application is vulnerable to SQL injection, then it's easy to get the database to send back contents of the database to the application's pages, to the application screen. So you could query, for example, somebody's bank balance if the bank was vulnerable, for example. But it's not just data theft, it's also integrity of data. You may want to change that data. You can do that, for example, with an update statement in SQL. There was and not so famous, but it was quite funny to see that there was a political party website. Their leader, prior to 2010, that image of that leader was replaced by a picture of Mr. Bean, who was more famous, of course, at the time. And that was done by a SQL injection attack. Now, that was a content management site with the database at the back end. So it was just a simple case of changing the table. Instead of pointing to an image of the then leader, it was pointing to an image of the very famous Mr. Bean. And then finally, availability. We saw, not so much now, but last year we saw a lot of prevalence of DDoS attacks in the press. And if you think again of SQL injection, you just send a semicolon, shut down, minus. You shut down the database. All of a sudden, you didn't need to bother flooding the network, you didn't need to do anything, you just shut down the database. So this is why application security is really important for PCI DSS and for organizations. So what can we do to address particularly requirement 6, which is to develop and maintain secure systems and applications? Well, what I do is I use runtime code and data analysis, which sounds rather complicated. Of course, I use some technology to do that. And one of the things it would address, among many other things, PCI 2 talks about the OWASP top 10. Now PCI 3 talks about standards top 20 and some other standards, but let's just look at the OWASP top 10 for 2013. Coincidentally, that changed just about, I think it was about three months ago, from the 2010 version that we had. Everything in blue has remained where it is. Anything in red has moved up. Anything in green has moved down in prevalence. And yellow is a merge of techniques. So injection, which I was just referring to in the last slide, that pretty much stays where it is. And by the way, this isn't just some nerdy types deciding on what's vulnerable or not. It's based on commonality and prevalence of the attack type, ease of execution, and business impact. What is the risk of business if this kind of vulnerability exists in your application? We see broken authentication session management has moved up, and it's moved up from A3, which is now taken by cross-site scripting, which has moved down. That was number 2. The reason for that is there has been a lot of talk about cross-site scripting over the last few years, and developers are now starting to understand, well, actually, if I'm coding this, perhaps I shouldn't allow this plain text to go straight through the application. So maybe I should put in some barriers against cross-site scripting. So we certainly see less now, and this rings true for OWASP. insecure direct object reference stays the same, but security misconfiguration, that you can see how the OSPF tends maturing. Now, this relates to encryption of data in transit and data at rest. There were two separate sections relating to data storage and data transit. That's now gone to A5, it's moved up. Anyway, I'll not talk any more about that other than just to say A8 has gone down. That's cross-site request forgery. It's particularly dangerous if it can be exploited, but it can only really often be exploited if cross-site scripting is there. Now that's gone down, of course. Cross-site request forgery has also gone down. Cross-site request forgery allows an attacker to make requests from your browser on your behalf, such as turn this firewall rule off, or make this balance transfer, and so on. So by using runtime code and data security analysis, what we can do is make application security implicit in each build, because right now, if you look at the way that applications are built, in many cases, you build the application, you have some security requirements at the beginning, they may or may not be adhered to. You get to the end, and then you get to a point where you're doing a penetration test. And the penetration test may well fail. At that point, it's a little bit late to address that because you've probably already gone live, or you are going live very soon. The point is to move application security left in the development lifecycle. And the best way to do that is, many of your organizations are probably using Agile and doing Agile developments. Therefore, if you can secure each release, each build that's done in this Agile process, then we could start to address application security. But traditionally that hasn't happened. And why is that? Well, there's static analysis of code, there's black box scanning, but there are some fundamental flaws there. Those types of technology have traditionally and still do deliver false positives, red herrings. And if you look at what that does to a process, it destroys it. If you have a piece of technology and it's constantly telling you, hey, you've got a problem here, it's not really a problem, then how often is a developer worth his salt actually going to look at that report? The stuff ends up on the shelf. And so there might be 100 vulnerabilities in there that are reported, maybe 2% are real. It's a lot of work just to find the real vulnerabilities. So what you need to have is something that's incredibly accurate. You need to, the technology must report on vulnerabilities and only real vulnerabilities that impact business data or business processes. So without that, you don't have a starter. Once you have that, the next point is clarity. So to have to be presented, look, hey, you've got a problem, it's not really enough. It's not like you go to your doctor and the doctor says, yes, you're ill, now go and find out why. We need to have clarity in the report. So here's a vulnerability, and here's where the code is. So by doing runtime code and data security analysis, we can track data flow through the application code. We can also say, well, this piece of code touched this data, so we can say this is vulnerable code. And then finally, to make the whole thing very simple, is because we know the kind of vulnerability that will be exploited with this runtime code and data analysis, we can say this is typically how you need to fix this kind of problem. So if you imagine that in a process, a fast-paced development process, then it goes from a lengthy test, a manual test at the end, to something that's run overnight, with a report that's presented in the morning with the vulnerability, the root cause, and the remediation. So the following build, that might be the following night. It can then realistically be addressed. So security kind of comes, application security, becomes something that kind of runs in the background in quiet mode, security/Q, I put there. And that means that you hear nothing very often from this kind of data if you've got a secure application, except when you make a build and you accidentally put in a vulnerability, and then you see the vulnerability. Ideally, you don't want to be seeing too many of these things, and then this technology actually gets listened to because it rarely speaks, but when it does, it has a lot of coverage. So, runtime code and data security analysis is an efficient and effective way to deal with requirement 3, 4, 8, and 11, and 6, so we'll just see. If you look, for example, at requirement 3, I'll quote it, keep cardholder data storage to a minimum by implementing data retention and disposal policies, procedures and processes. So if we look at what that means for application security, by automatically identifying cardholder data at the front end of the application where you're putting in your PAN, and then saying, I see this data at the front end, I see it in the middle tier, I see it going across to the database, and I see it hit the database. You can then say, well, was it encrypted at all those levels? Is it being stored somewhere encrypted? Is some crazy developer logging all of this information to a log file for malicious or non-malicious reasons? If you look at requirement 4, encrypt cardholder data over open public networks, well, I think I've covered that there. By identifying cardholder data, we can see exactly where it goes. If it goes off to a third-party source via an unsecure channel, it would be highly unlikely, I think, these days, then it can be identified. And requirement 8, assign you a unique ID to a person with computer access. So if I just look at the actual data there, the actual requirements, 8.4, render all passwords unreadable during transmission and storage on system components using strong cryptography. By the same way that you can identify PANs, cardholder data, you can also identify other critical data, such as passwords. So if I see a password go from A to B and it's not encrypted, particularly over the internet, which isn't that uncommon, then I can highlight it very quickly. If I see it go from C to D and it's not encrypted and it's internal, then that's probably okay. And then finally, requirement 11, which pretty much is what this whole thing is about, and that is to regularly test systems and processes. Well, by having this thing embedded into an application security development, an application development lifecycle, then security becomes automatic. It just goes away as a headache. And it means that you can move application security left in the development lifecycle, which there's at least two good reasons to do that. You reduce risk and you reduce cost. Bugs are introduced. So this is a Capers-Jones graph. It's something that application quality organizations, particularly vendors, use a lot. And it talks about vulnerabilities, not vulnerabilities, but quality issues in software. But application security vulnerabilities are in fact bugs. They live in the code. And those bugs are created by developers in the creation process. Now, they're discovered at the first point of testing, and that is the most cost-effective time to discover them. If we look at the difference between finding them after release and finding them during unit tests, it speaks for itself. We will find more vulnerabilities further on as we start to plug together other parts of the application. But really, if you're doing a continual process of testing, then you're going to find everything. So how does that work then? Well, if we look at what's actually happening when we do a transaction with an application, we have data going in, cardholder data going in, critical, sensitive data going in to the front end, which is a web server presentation layer. And that's analyzing a protocol, it's being sent HTTP or HTTPS, it's decrypting and decoding what is being sent. And where necessary, it's calling business functions, which are running on the application server. And they might be user libraries, they might be runtime libraries, they might be third-party libraries, and that's important because if it's third-party library and it's got a vulnerability, is it your problem? Well, it is, because your code, their code becomes your code because you're running it, and it's making data vulnerable that you're responsible for. And of course, that is then making requests to the data layer, typically a database, which is running stored procedures, which are managing the data. And then it goes all the way back up the chain. At any point in that chain, there could be a vulnerability at the code layer. So by doing this, by analysing the data and tracking it all the way up and down the application stack, we can say, for example there where we've got the binary, okay, this code was managing that data at that time. We saw it go in, encrypted, and it came out unencrypted to the database, for example. I can tell you then that this is a vulnerability. Or it's not screening for SQL injection calls. So I can tell you this code needs to be addressed to filter out injection. So really, in summary, PCI it gives us extensive guidance in achieving strong application security, but it shouldn't be the ultimate yardstick. Meaning, if you've fully complied with all its requirements, it still wouldn't guarantee you for an impenetrable system. Cyber criminals are always looking for new ways to come up with attacks, and application security undertakings should therefore be an ongoing exercise. If you look at PCI DSS, you become compliant, and you're compliant for that release. But then you make another release. Are you compliant? But if you were to be tested, maybe not. So it's a point-in-time exercise, but by implementing a process of continuous security evaluation, then you can go a long way to making sure that, at least for the application perspective, applications are secure. So that's it, really. Just want to say this is my company. I'm a UK manager for Quotium, and we produce this Seeker software. If there's any questions, please let me know.
Any questions from the audience? No?
Thank you very much.